So we've been working with polynomial expressions, right? And we talked about what it means to be a polynomial and degrees of polynomials and classifying them by number of terms. Now we move on to polynomial functions. And polynomial functions are just very simple to create, right? All you have to do is, if you have a polynomial expression, 2x to the third minus 3x squared plus x minus 2, that would be my polynomial expression, right? And it's a third degree, because again, I had mentioned this briefly at the end of the last video. If there's only one variable, it's very easy to determine the degree. The degree is just whatever the highest exponent you see of the variable there. So in this case, the highest exponent I see is 3, so that's actually a third degree polynomial expression. All right? And I can just turn this into a function very easily by just placing f of x in front of it. So if I declare f of x to equal 2x to the third minus 3x squared plus x minus 2, I've now created a polynomial function. And this is the third degree, and again, I mean, this is just more terminology stuff. It's not super important, but a third degree polynomial function is going to be known as a cubic function, because it's third degree. And if I took some general second degree polynomial expression, and I'm going to call this one g of x, that's now a second degree polynomial function, which we would call a quadratic function. All right, so a second degree polynomial function is a quadratic function. A third degree polynomial function is a cubic function. A fourth degree is actually called a quartic function, and a fifth degree is actually called a quintic function. But generally, in this class, we deal mainly with quadratics and occasionally cubics. So that's just the basics of the functions. So what can we do with these functions? Well, you can do a lot of things. I mean, the most basic thing, obviously, is just evaluating them. So if we had our cubic function from before there, which was f of x, I'm going to have to scroll up again to see what it was. It was 2x cubed minus 3x squared. So 2x cubed minus 3x squared plus x minus 2. And I want to evaluate this maybe for x equals -1. What does it mean? It basically just means substitute, right? Substitute or plug in the value -1 for x and figure out what y is. All right? And I mean, you did this in the first unit. We had problems where you would evaluate functions at various values, right? Sometimes they were actually polynomials. We just didn't call them polynomials at that point, but now we're calling them polynomials. So if I evaluate this function f of x for x equal -1, what am I really finding? Function notation-wise, I'm finding what we call f of -1, right? And again, it's just basically what I wrote in the box up there. You're just plugging in or substituting -1 for x. So you would write this as 2 times -1 to the third minus 3 times -1 squared plus -1 minus 2. And this one could be a little tricky with signs here, right? Because when you cube -1, you get a -1. So this is really 2 times -1. When you square -1, you get a +1. So this is really -3 times 1. Plus a -1 is really -1, and then -2. So this is really -2, -3, -1, -2. So it's actually 4 negative values that are going to combine to give you a bigger negative, right? So then this is -8. Really a smaller negative, right? When I say bigger negative, I mean bigger absolute value. But so it's -8. And again, function notation, I would say that this is f of -1 is equal to -8. Because again, remember the idea of function notation is it's just basically another way to write an ordered pair. Okay? So I would just say f of -1 equals -8. And I could have done this on the calculator also, because sometimes these get kind of crazy number-wise. So if I want to do this on the calculator, I would go into y1, right? And I would enter that function. So I'd enter 2x to the third minus 3x squared. When you're going to do x squared, you can just use that x squared button instead of having to do caret 2. So 2x cubed minus 3x squared plus x minus 2. And all I need to do really is, I wouldn't go to the graph necessarily. If I just want to evaluate it at -1, I would just go to my table. So I press second graph, and now I can see in my table that when x is -1, y is -8. Right? So again, the calculator table can save you a lot of work. Right now, if I wanted to evaluate it at 5 or something, all right, at 5 it's 178. If I wanted to evaluate it at -8, at -8 it's -1226. Right? So the calculator table can save a lot of work. Okay? So that would be just evaluating a polynomial function.